Hey guys, okay, so in this video, sorry, I am still getting over from being sick. So in this video, the first video I made tonight, we talked about how to do our setups and remembering what bridge we're building every time we're doing each of the conversions. That if it's a mole ratio, if it's a mole to mole, we always use a mole ratio. If it is a mole to grams, we always use a mole ratio first because we started with a mole and end with a molar mass for a double T. Then from grams to moles, we start with a molar mass because we started with grams, and we end with a mole ratio because that's who we're ending with. And from grams to grams, we have a triple T chart. And because we started with grams, we have to go from molar mass to a mole ratio so we can switch our elements or compounds and end with a molar mass. So now what we're going to do in this video is we're going to, over here, I'm going to go ahead and do for you B. 7.3 moles of H2O are produced in this reaction. How many grams of NH4NO3 will react? So, first things first, and you can see that it's partially done over here on the study guide, the study help guide. Now remember, that is posted on eClass already for you. So you just need to go under Content, Unit 2, and look for the title Study Guide Help. So let's work that problem out. So I have my double T because I am going from mole to gram. So we're using this one right here. I'll line them up so you can see them. So we're using this example. So our given goes right here. This is our given. And they told us in the problem that I have 7.35 moles of H2O. Now, from our example, our first conversion, our first thing that we're going to be doing is a mole ratio. So, moles of hydrogen automatically go on the bottom. That already tells you that. Now, because we're trying to get to NH4NO3, we're going to do the mole ratio to moles of NH4NO3. So this whole section right here is a mole ratio. So when I look at the balance equation, I know that this is missing some numbers. For the record, that's 1 in oxygen and 2 in nitrogen. H2O has a coefficient, the big number, not the little number, in front of 4. So he gets a 4. Then NH4NO3 has a 2 in front of it, so he gets a 2. Now, the next part is going to be a molar mass. So, we know that with molar masses, that it's always 1 mole of the molar mass, which in this case is going to be NH4NO3. So NH4NO3 for this conversion. to grams of NH4NO3. Now, to find the grams of NH4NO3, we are going to have to look at the periodic table. Now, we have N, we have H, and we have O. We have 2 N's, we have 4 H's, and we have 3 O's. When you look at the periodic table, nitrogen has an AMU of 12.01, giving me a 24.02 amount for nitrogen. For hydrogen, we have a 1.01. So when you times that by 4, you get 4.04. Then for oxygen, he has an AMU of 16. So 3 times 16 is 48. So now, since we have each of those amounts for each of the individual elements, we can add them up. So 48 plus 4.04 plus 24.02 gives us 76.06. So now, because I have 7.352 and 76.06 on top, I multiply them. So when I multiply them and divide it by 4, because 1 times 4, the 1 right there times 4 is just 4, it is going to give me the 294.22 grams of NH4NO3. There. So that is a mole to gram conversion. For you guys to be able to do this, all you need is a balanced chemical equation and a periodic table. All right, next one, because I'm going to do 2 on here. The next one I'm going to do is this one. Let me slide it over. We're looking at 13A. So they're asking you, they already give you a balanced equation right here. How many grams of water will be produced if 38 grams of oxygen react accordingly to the following equation? So we are doing a gram to gram conversion. Slide this in some. So we will be doing, for the next one, right here, the gram to gram. So the first step in gram to gram is going to be the molar mass of our given, then the mole ratio, then the molar mass of our desired. And it's going to be set up with 3 T's for the 3 T chart. So first off, 1, 2, 3. I'm going to make them a little longer. The given always goes up here. So my given in this case was 38 grams of O2. So down here, for our molar mass, because we started with grams, This whole area is going to be our molar mass. And remember that it's the grams of O2 that we find on the periodic table to 1 mole of O2. Again, molar mass always has 1 mole to the grams, or grams to the 1 mole in your setup. So, O2, O has 16 AMU, atomic mass unit, giving me 32 grams of oxygen. Now, the next one is going to be our mole ratio. So we look at our given our balanced chemical equation. I'm so sorry, guys. So oxygen has 15 and H2O has 6. So because moles of oxygen are on top, he's going to go on bottom automatically. So moles O2, already decided. And I'm trying to do the ratio of moles of oxygen to H2O. So mole H2O. Moles of oxygen were 15, and the moles of H2O were 6. Someone's dogs are barking. Now, this isn't where we stop. We're not trying to get to the moles of H2O. We're trying to get to the grams of H2O. So that's why he has a third step. Third step right there is going to be your molar mass for your grams. So, again, because moles of H2O are on top, he has to go to the bottom. So that's moles of H2O. And we know that with molar mass, our pink, that it's always 1 mole of that desired, the H2O, to the grams of H2O. Now again, we have to refer to our periodic table. We know that hydrogen for H2O has 2 times 1.01, giving us 2.02. And then oxygen is 1 times 16, giving us 16. When you add 2.02 plus 16, you get 18.02. So I put my 18 that I just solved from my periodic table up here with my grams, 18.02. Now, everything is inputted into our conversion. So you take 38 times 6 times 18.02. But because there's 2 whole numbers down on the bottom, you have to multiply them first. 32 times 15. So let's do that. Have my handy dandy calculator. So 38 times 6 times 18.02 gives me 4,108.56. So I'm going to put him on top. Then 32 times 15 is 480. And when I divide those, I get 4 4108.56 divide 480. 8. It is so hard to work around this box. 0.56 grams of H2O. And that is my final answer for problem 13A. All right, I just showed you a mole to gram and a gram to gram problem. Please let me know if you need me to work out any other problems or if you have any other questions. Both of these style of questions will be on the test tomorrow, so please know how to set them up, making sure that they are aligned where they can cross off. The biggest things I saw on the study guide today was putting and doing the wrong thing, meaning that you were either doing molar mass when you should have been doing a mole ratio, or doing mole ratios when you should have been doing molar mass, or keeping, for some reason, some of you, keeping the same element across and the same one on the bottom, which doesn't work out. So make sure that you crisscross them out so that way you end up with just the unit of what you want, your desired. Hope you guys have a great night. Make sure to study.